Now let's just move on further towards the question number 2, which is nothing but in figure it depicts a racing track. So let us suppose we have this figures. This is our figure, and it says in figure it depicts a racing track whose left and right ends are semicircular. So as you can see all by yourself, these are semicircular, and the distance between the two inner parallel lines is nothing but 60 meters. So as you can see, this is nothing but 60 meters, and they are each 106 meter long. So this is actually 106 meter long, and if the track is 10 meter wide, it means this portion is actually 10 meter wide. As you can see over here, this is 10 meter wide. Find the distance around the round track along its inner edges. So we just have to find out the distance which is around this round track along the inner, means we are just talking about this inner area. That is nothing but the distance which is covered by this inner track, not the area. We just have to find out the distance which is around, distance, not the area. And in the second part we have to find out the area of the track only. So let's just calculate one by one. First of all, let us suppose as you can see in this particular figure, I have already given a lot of names over here, means I have taken this particular point as A, I'm just taking it as B, I'm taking this as C, I'm taking this as D, and furthermore I have taken these two straight lines along this A, B and C, D points in such a manner such that I'm calling this point of intersection as E, I'm taking the center as O, and I'm just taking this point of intersection as H, and further I'm taking this point of intersection as F, the center of this particular semicircular portion as O dash, and this point of intersection as G. So I have taken these particular points in order to find out the area for this particular area of the track and the distance along the round track along its inner edge. So let us suppose if I'm just starting with the very first part in which we have to calculate the distance around the round track along its inner edge only. So for the first part, starting with the very first part, as you can see, we have to find out the distance around the round track. So the distance around the round track along its inner edge should be is equal to, as you can see, this should be is equal to, we have the two semicircles over here, you can see all by yourself. So this is my first semicircle, this is my second semicircle. So as you can see, we just have to find out the circumference of this particular semicircle, because we just have to find out the distance only. So hence we have to find out the circumference of this semicircle, the circumference of this semicircle. So both would be equal to each other. So we will say it would be nothing but is equal to twice into the circumference of the semicircle, the circumference of the semicircle, and further we have plus, as we have taken the circumference of these two semicircles, but we are left out with these two straight lines, that is nothing but EF distance plus HG distance, because this will provide us the whole total distance. So plus of EF length plus of HG length. Now let's just plug in all the values over here. This would be nothing but 2 into circumference of the semicircle. We know that the circumference of the circle is 2 pi r and the circumference of the semicircle is pi r. So this will be 2 pi r plus of EF. You can see over here that EF is actually 106, which is definitely is equal to AB again. If this is 106, then this is also 106. This is section, or we can say this length is also 106, and moreover again HG is also 106. This is again 106. Now further, let's just calculate. We are using pi as 22/7 over here, and the radius, you can see the radius is nothing but the radius, as you can see over here, the diameter is nothing but given to us as 60. So the diameter for the inner semicircle is actually given to us as nothing but is equal to 60 meters. So it implies the radius would be is equal to 60/2, which is nothing but 30 meters. So hence the radius is nothing but 30. So this would be 30 plus of 106 and 106. So this would be nothing but 212. This would be 212. Now again, let's just sort it out. This would be nothing but 44 into 30 divided divided by 7 plus of 2, 1, 2 and 1. So when you will just take out the LCM of all these values, you will get the answer as 2804 by 7. When we will sort out all these values over here, we will get the answer as 2804 by 7, and hence this is nothing but the distance which is around the round edge along its inner edge. So this is nothing but 2804 by 7 meters. You can further sort it out. Let us suppose if I'm just leaving it around here. So this is the answer for the very first part. Now let's just move on further towards the second part. In the second part, we just have to find out the area of the track. We have to find out the area of the track. So let us suppose if I'm just moving on further by towards finding out the area of the track. So as you can see, if we are just talking about the area of the track, it means that we are talking about this particular track, and again in order to find out the area of this particular track, we first of all have to find out the area of this particular section. So as you can see, if I'm just taking this section only, then there are two semicircles over here, the inner one and the outer one. So if I'll subtract the area of the outer circle with the inner circle, then I will get the value of this particular shaded region. And furthermore, this area is equal to this area. You can see all by yourself that this is all symmetrical. If I can able to find the area of this particular circular track, then I can able to find out the area of this track similar to this one. And furthermore, we just have to find out the area of this particular circular of this particular track, and you can see all by yourself that this ABEF or ABFE is actually forming a rectangle over here. So considering it as a rectangle, we can able to find out the area of this one and this one similarly. So let's just calculate the area for these semicircles first. So let us suppose if I'm just finding out the area of this E, D, H and E section. Let us suppose if I'm calling this as nothing but let us suppose if I'll take it as S point. Let us suppose if I'm taking it as S point. So first of all, we are starting with finding out the area of ADHSE. So this would be nothing but is equal to the area of the outer semicircle minus the area of the inner semicircle. They should be of this form. So let's just calculate it. We know that the area of the semicircle is nothing but pi r square by 2. So this would be pi r square by 2 minus of again the area of the inner semicircle. Let us suppose if I'm taking this radius as r1 and I'm taking this radius as r2 whole square divided by 2. Now first of all, we know that the radius for the inner semicircle is nothing but 30. So what is the radius for the outer semicircle? Now you can see all by yourself that if this particular radius is nothing but 30, if this is 30, then we know that the width of this track is 10. It means that this width is actually given to us 10. So it means that if we are just finding out the radius for the outer semicircle, this would be 30 plus of 10. This would be nothing but a 30 plus of 10, and 30 plus of 10 is nothing but is equal to 40 meters. So hence the radius for the outer semicircle is nothing but 40 meters. So let us suppose if I'll just plug in the value over here, I'm taking pi by 2 common out of it. So this is nothing but r1 square minus of r2 square, and this is nothing but pi by 2, and r1 square I'm taking, r1 is actually nothing but 40, so this would be 40 whole square minus of r2, we already know this is nothing but 30, so this is 30 whole square. Now let's just sort it out. This would be nothing but pi by 2 into of. So this value would be nothing but 40 square minus 30 square. Let's just calculate it. So this would be nothing but 1600 minus of 900, and this is, let us suppose if I'm using pi as 22 by 7 because we have already taken pi as 22 by 7 in the very first part. So this would be 22 by 7 into of 700 and 22 by 7 into 2. We have this 2 in the denominator as well, into 700. So this would be 100. This would be nothing but 11. So at the end we are getting 1100 meters square, the area of the ADHSE. And now we know that if this area is nothing but 1100 meters square, then this area, let us suppose if I'm just calling this particular point as nothing but V, let us suppose if I'm taking it as V. So in the similar manner, so let us suppose if I'm writing over here that similarly the area of I'm taking B, C, G, and we have taken it as V. F would be nothing but is equal to 1100 meters square, 1100 meters square again. Now let's just calculate the area of the track. So the area of the track would be nothing but is equal to the area of ADHSE plus the area of BCGVF plus the area of the rectangle, which is ABFE plus the area of the rectangle again, which is nothing but HGCD. Now let's just plug in all the values over here. So first of all, we know that through two areas as 1100, so this would be nothing but 2200 plus of the area of the rectangle. You can see over here the area of the rectangle is nothing but length into breadth. So the length over here is nothing but 106 and the breadth over here is nothing but 10. You can see all by yourself that the length is 106, the breadth is 10. So this would be nothing but 106 into 10 plus 106 into 10. So we are actually getting the answer as 2200 plus of 1060 plus of 1060, and at the end after the addition of all, so you can see all by yourself that we are actually getting the area as nothing but 106 into 10 of this particular rectangle. So at the end when we'll add all these values, we will get the answer as 4320, which is nothing but the area of the track, meter square. So at the end we are getting the answer as 4320 meters square, which is nothing but the answer for the second part of this particular question. So this is all about the question number 2.